Hello class, I hope all is well and you guys are doing well too. I'm gonna increase my volume to the highest. So we are gonna go over chapter 10 and that is for the third exam material, if I'm not making a mistake. Don't quote me on those things, but anyhow. So the respiratory system, that's the title of this chapter. And of course, as I said before, I'm not going to go over these learning outcomes and so on and so forth. So I don't know, I want you guys see me a little bit bigger. Okay, that's bigger. I think that's, and you can see my son's bed and you can see the door and the light. You can see the whole house. So you can come to the house and you know your way around. Okay, I'm not sure if I can keep this chapter to 30 minutes, but I do my best. I try to talk fast, but wherever I slow down and wherever I emphasize things maybe more than once, you should pay attention. They are important. And wherever I go, breeze through, just talk very fast, then, you know, they are probably not that significant in this chapter. And I try not to delete any slides that comes with the book. So that's what happened. Anyhow, so ventilation, you know, it's just breathing. That's what inspiration and expiration is called, ventilation. And of course, you know, as the whole body, it works together. So our respiratory system is needed with our cardiovascular system, the heart that pumps the blood throughout the body, which you studied it before. And then what happens, we are terrestrial animals. We need the oxygen. Of course, aquatic animals need oxygen too. So we need the oxygen to get into our cells, and our cells use that oxygen is called cellular respiration to break down glucose, the mashed potato you had for breakfast, and then to give you energy, okay? So when we inhale oxygen from the atmosphere and we give off carbon dioxide by our cells, these carbon dioxides need to leave our cells. That is happening by our respiratory system. Of course, it happens, our cardiovascular systems, the red blood cells are like a messenger, if you would. They take the oxygens from lungs, they take them to the tissues of the body, liver, muscles, brain, and then they pick up carbon dioxide from them, and then they go ahead and bring it to the lung, and we exhale it. Okay, I hope I'm making some sense. So that's what's happening with the, not just the big picture of the respiratory system. So I had a professor in Kentucky. He used to say, bless his heart, great guy, Dr. Kennedy. He was a veterinarian, but anyhow, he said that your respiratory system is like a tree. Imagine a tree. This is the trunk of the tree, and these are the branches of the tree. And attached to these branches are little leaves or leaflets here, or if you would, I'm going to need these little balls. These are the leaves that are on the tree. And then take that tree right here and upside down it and stuck it down your throat. That's what your respiratory system is. Okay, I hope I'm making some sense. So here is your nose. You know, you can breathe, you can inhale air from the atmosphere, either through your nose or through your mouth. So that's why they did draw nose and the mouth. They didn't draw mouth right here. So they didn't label it, they draw it. And then after the nasal cavity, the nose, there's pharynx, okay? Pharynx, where the pathway of the food is right here in the pharynx, and also the air. And then after that, glottis is the vocal cord and spaces between them, opening of the larynx, and larynx is the next one, voice box. That's where you make your voices. And after that is trachea right here. And trachea branches, that's called upper respiratory tract. Okay, upper, this is called lower respiratory tract. From the lungs, of course, the bottom portion of the trachea, and then the lungs. Well, let's go back to this diagram. I'm sorry. I should follow the diagram. Trachea branches to bronchioles, and bronchioles branches to bronchioles. Like you have a main branch of the stem, and you have branch and branch and branches, branch more, and branches branch more. Okay, and then at the end of the branches, then you have the alveoli, the air sacs right here. Okay, at the end of the branches, as I did show to you. So these would be examples of your alveoli, which I will show them to you later on. We'll talk about it a little bit. And on the bottom of your respiratory tract is a diaphragm, which allows, it pushes the lungs up and down. Okay, so having said that, the upper respiratory tract consists of nasal cavities, pharynx, and larynx, or nose, and there is a nostrils between the septum, between the nostrils. This is a nostril, this is a nostril, and there is a septum between them. So, and then of course, inside of your nose, you have hair to protect you from inhaling. And I will talk about more protection a little bit later on in the trachea. So the hair of the nose will protect you from, getting dust, parasites, bacteria. It's just a little bit line of defense for you. That's why you have the hair in the nose. So this is the upper respiratory tract. Everything we talked about. Later on, I'll come back to it and I will talk about it a little bit later. Here is the epiglottis. I would like to mention that quickly because it's important. Epiglottis is a flap of cartilage, okay? So when you're eating, that flap of cartilage closes the trachea. Food should not go into trachea, right here. Food should go into esophagus. We already talked about that with the digestive system. So when the flap of glottis closes, the food does not go into trachea, and then you're safe. If that doesn't work, then Houston, you've got a problem. Somebody will choke, and then you better take care of that. The nasal cavities under mucus, lined with mucous membrane. We talked about, mucus in the past. So your respiratory tract, the very top layer, it has to be wet and moist. It cannot be dry, okay? And then that's what this PowerPoint is saying. And then inside of your nose, of course, you have the odor receptors, okay? One of your 5 senses are your odors. And of course, then he talks about tear glands in the eye drain into the nasal cavities by way of tear ducts carrying, causes a runny nose. And then the nasal cavities also connect with sinuses, which are inside of your skull. Right here are your sinuses. And then the fluids may accumulate in these sinuses, causing an increased pressure or headache later on. The nasopharynx is a combination of the nasal and pharynx. And then, of course, you have auditory canal. If you have a cold heavily, your auditory canal can be kept there. It can be eustachian. They call it eustachian. Another name for our auditory canal is eustachian tubes. It connects nasopharynx to the middle ear. And then we'll talk about the disease of that. When the pressure inside of the ear is equalized with the air pressure, nasopharynx auditory opening create a popping sensation. Pharynx is the funnel shape that connects the nasal and oral cavities to the pharynx. And you have 3 regions of nasopharynx, oropharynx, and laryngopharynx. So at the end, you have tonsils. They protect you. It's like the biggest lymph in your body. We talked about lymph nodes, lymph glands. They are the biggest lymph gland in your body. There are tonsils in the back, and you will see the picture of it. And what happens is tonsils will protect you against bacteria that you inhale, you eat food. Larynx, or your voice box, is a cartilaginous structure between pharynx and trachea, Adam's apple, it is your laryngeal prominences. It's located at the front of the neck. And then the vocal cords are in your larynx. Of course, you make the noise. Everybody has a different pitch because of the vocal cords, and everybody's different, and so on and so forth. And the glottis is the slit between the vocal cord and is called between the vocal cords, I should say, there are four of them. It's called glottis. When air passages through the glottis, the vocal cord vibrates and so on. The greater the tension in the vocal cord, the higher the pitch and so on and so forth. I'm not going to worry about that too much. Right here is a real picture. This one is real picture. This is a drawing for you guys. So that would be your tongue right here. That is your tongue. And then your epiglottis, it's a flap of cartilage right here. We talked about that. And then these are your vocal cords. Right here are your vocal cords. And this is your glottis a little bit lower down, right? This area, that is your glottis. So larynx continued, as I said, epiglottis covers the trachea, so food will not go into epiglottis. Lower respiratory, that was most everything that you should have known about upper respiratory tract. The lower respiratory tract is your trachea, bronchial tree, lungs, which I will talk about each one of them, commonly called a windpipe. The trachea, as I said, imagine this tree, upside down it and stuck it down your throat, the tree, and then the trunk of the tree is your trachea. So right now, trunk here. Another name for it is windpipe. Another name for larynx is your voice box. Anyhow, these are common names that are given to it. Connects the larynx to bronchia, bronchi, and its walls are reinforced by C-shaped cartilage. So your trachea is made up of C-shaped cartilage, right, like this way, okay? They're so the trachea does not collapse. As you know, your esophagus is collapsed. When food is collapsed, it's made up of smooth muscle. And then when you are swallowing food, it goes through, but your trachea cannot collapse. Okay? It has to be a nice round, and then they are protected by a C shape. I should not draw them like that. I should have them like this, C shape on top, C shape on the bottom, something like that. Okay. So, and of course, your trachea is covered the mucosal layer of trachea. If I draw this in a cross section, so these are the cilia, ciliated cells, which is cilia right here is called pseudostratified. When you look at this layer right here, you think it's it's more than one layer, but in reality, it's one layer. That's what they call it, pseudo false stratified. Pseudostratified columnar ciliated columnar epithelial tissue. And embedded with them are goblet cells. And what is the function of goblet cells? You learned in the last chapter. They release mucus. You got it. Okay, so they release mucus on top right here. So the mucosal layer is wet and moist. You remember I talked about these hair in our nose. They protect some, you know, when the air has dust, or not hair, all of the air has dust or other particles that get into our nose, the hair protects them a little bit. Then the rest of the air that goes inside into our trachea, the windpipe, these cilia push the particles up into our throat. And then you clean your throat in the bathroom, not in the hallways of Delta College. I hope I'm making some sense. Okay, so that's what the purpose of these cilia are. The cilia push the particles, whatever they are, hopefully they will not go to the lung, they push them up into the respiratory tract, the upper respiratory tract. Remember, trachea is a lower respiratory tract. Trachea continuum is pseudostratified. I think everything I talked about here, except this term on the bottom, smoking dangerous, of course, the cilia. Tracheostomy is the breathing tube inserted into the trachea that when we had the conference at Delta College, the medical students from Davis used to come and demonstrate tracheostomy to the students, how they put a tubing, ventilation tube into the they had a model. They put it in there. Bronchial tree, I already talked about that. It branches and branches and branches, so I'm not going to talk about that anymore. At the end of the bronchioles, the smallest branch of the tree, there are leaves of the tree right here. I hope you guys can see that. So these are bronchioles right here. They're little balls, equivalent to analogy of the tree that I gave you. They are like a leaf, but in reality, when you look at them on the microscope, which we do have slide of them, they're little balls right here. And right here, bronchioles attached to it. Okay, so a bronchiole is attached to it, and a bronchiole is attached to this one. So right here are the balls are alveoli, or they call them air sacs right here. Common name air sacs, medical terminology for them is alveoli. Alveolus is singular, alveoli is plural, like villus. You learned that in last chapter, and villi is plural. Okay, very good. Right here, that's a bronchioles, and it goes to this little ball-shaped things. And around these balls, if you would, around these balls, there are capillaries right here. They're surrounded by capillaries. So the capillaries can pick up oxygen, and then, of course, inside of capillaries, you learned that before, there are red blood cells, and they give off carbon dioxide. That's the idea of respiratory system. So right here are alveoli, and then here are capillaries. They pick up oxygen from the arterioles. Remember that? Arterioles branch to capillaries. And then the other end of the capillaries are the venules. Remember that? That's venules. Okay. So the venules pick up the carbon dioxide. So venules pick up CO2. The red blood cells pick them up and take them to venules. You know that. And then arterioles, they carry oxygen into the alveoli. Anyhow. So lungs made up of secondary bronchioles and so on and so forth. Each lung is enclosed by membrane called, yes, that is very important. I didn't talk about it, so let's talk about it. So your lung is covered by a sac, which is called pleural sac, which secretes pleural fluid. So the lungs, if you would, the lungs are rubbing against your ribs and the muscles, okay, of your, there is a layer of course, tissue, connective tissue between the ribs and the lungs. So that surface of the lung has to be lubricant, and I will talk about that surfactant here in a minute. If it is no lubricant between the ribs and the lungs, but they are constantly, your lungs are moving up and down, then the friction will destroy them. Your lung tissues will be gone. Okay, so there should be a surfactant. We didn't talk about that yet. Okay, he will come up. The pleural fluid surface tension, which adheres partial and visceral pleural, which I did talk about that. Pleurisity, inflammation of pleural, painful. Yes, if that the pleural fluid, the pleural membrane becomes infected, then you have a basic condition called pleurisy, inflammation of pleural. Okay. Alveoli, about 300 million alveoli. The lungs have 300 million alveoli. Do not worry about that number. The alveolar sacs, air sacs, surround the capillaries. I think I talked about that. Everything in here I talked about. Alveoli. Here we go. Surfactant. That's what I was concerned with. That it's coming up or not. Yes, it did came up. The alveoli are lined with surfactant, a film of lipoprotein. So you all know what is a lipoprotein. It's a protein molecule attached to lipid. Okay, so a lipoprotein that lowers the surface tension, as I talked about that, the surface tension, right here is the surface tension, okay, of water and prevents the alveoli from collapsing. Very important. Infant respiratory distress syndrome, when the premature infants do not make enough surfactant, the protein, the lipoprotein molecule, the alveoli can collapse. Okay. Mechanism of breathing. At the beginning of this lecture, I talked about it. Ventilation is breathing, inspiration when you expiration is occurs. And the two facts, normally there is a continuous column of air in the pharynx and alveoli. Rib cage, of course, very important. The ventilation, he's talking about ventilation. Intercostal muscles, very important. You should know this. I definitely will ask a couple of questions about it in your exam. Are the bone, the meat between the bones, the ribs. Okay, these are the ribs, and in between them, there are meat. You've gone to the restaurants and you ate ribs of pigs. I don't eat the ribs of pigs, but if there's cow ribs or sheep, I don't know if they sell sheep ribs. Yeah, they do. Costco does. The cow ribs, I do eat that meat. It's very good, very delicious. It depends what kind of sauce they use. But anyhow, so what happens if the intercostal muscles, they can expand and close the ribs, okay? You know that, okay? And the diaphragm on the bottom, of course, it goes down and up, in which case it goes down. During ventilation, inspiration, it goes down. With expiration, it comes up, okay? So the lungs adhere to the thoracic walls, and then the space between the two pleura is minimal and filled with pleural fluid. Ventilation, do not worry about this. You know, your textbook did not go and talk about this. So Boyle's law, you take chemistry, you take physics, they talk about it. This chapter didn't talk about it. I guess when you take physiology, they will talk about it to some extent, but Boyle's law, I'm not too crazy about it. Okay, inspiration. The first step of your textbook is using inspiration. The first step of ventilation. Ventilation is made up of inspiration and expiration. So diaphragm and intercostal muscles contract. My diaphragm went down, my intercostals contract. Right now, I'm inspiring, okay? And then that's all of it. What happens, there is a little bit of information I'm gonna give you, I guess atmospheric pressure and all of this, you should know that information right here. So during inspiration, which happens automatically, okay? So every breath of your life, don't think about it. Of course, the medulla oblongata, there is a center that controls the your normal breathing, okay? So what happens, the pressure in the atmosphere is greater than the pressure in my lungs. So atmospheric pressure is greater than the pressure in lungs, the air automatically goes in, okay? Then the pressure in the lungs during expiration, that is inhalation. When the pressure in the atmosphere is greater than the pressure in the lungs, that's inspiration. During exhalation, expiration, the pressure in the lungs are greater than the pressure in the atmosphere. So the air is pushed back. Of course, diaphragm and the intercostal muscles, they're helping out. When you're sitting down watching TV, you're not thinking about your inhalation and expiration. When you meditate, you do think about, you should, that's the idea of meditation, you should think about your inhalation and exhalation. When you, at night you're asleep, you don't think about your inhalation, exhalation. So that happens automatically for you with help of your nervous system. So that is the part I would like to share with you. Okay, here we go. This is during the air pressure. Here is moves, the air pressure is greater than inside of the lung than alveolar pressure. So the air pushes in. Then the pressure inside of the lungs during exhalation becomes greater. So then the pressure outside, Boyle's laws, okay? I talked about that. The pressure is greater here than outside here. So the air is forced out. The air is forced in. So that's Boyle's laws. But anyhow, again, I'm not going to go ask any question about which law is this and that. I don't think you should worry about it. But anyhow, you already talked about it. If I ask any question about Boyle's laws, right here, that's it. This is the one. Okay, now here's a diagram showing you during inhalation, inspiration, what happens today. Look at the whole entire rib cage expands. Okay, so on. Okay, expiration, shrinks. Okay, the passive phase of breathing, the ribs, and so on and so forth. Here is expiration, is smaller, the ribs. Then the costal muscles go inside, they relax, so the rib cage becomes small. Surfactant keeps the alveoli from collapsing. I talked about that a little bit. Recoiling when accidents happen and something goes through the thoracic cavity is punctured, that's very dangerous. Air enters the space between the two pleural, causing the lungs to collapse, and that is very important. That's what the tracheostomy, as I talked about it, so the patient will not die. Maximum inspiratory efforts, forced expiration, and so on and so forth. That's okay. Expirations, the forced expiration. I will talk about all of those. Tidal volume, vital capacity. I think when the diagram comes, I'll share it. Okay, so I don't have to say it right here. Is a diagram that I want to do. So the normal breathing inside of your lungs is this, which is called tidal volume. Just normal. That was not a tidal volume. That is when you are asleep, you are watching TV, that's tidal volume. The amount of the air that goes in and out of the lungs, okay? So, and they gave you a number, I'm not too crazy about those two numbers between 2,400 to 2,900. Now, what happens when you take a deep breath and you fill your lungs with air? That's called maximum inspiration right here. And then it's called inspiratory reserve volume. That is a reserve volume in your lungs, okay? And then your vital capacity is the maximum expiration and residual volume and residual volume right here. It means you have extra space in your, as I talked about it before, in your trachea, you have a little bit of air, no matter how much you exhale, all of the air out. If you exhale all of the air out, there's still some air, about 1,200 atmospheric pressure, milliliter. So it is in your lungs, right there. So what happens, everything, that residual volume and everything in your lung, it's called total lung capacity. What is vital capacity is that everything which is in your lung minus the residual volume. That is called vital capacity. Okay, that's the one you have control over. You have control over of how much air you can put in your lungs, extra air. This is normally you in and out, tidal. This is how much you can exhale. That's the one you have control, let's say. Okay, but the total lung capacity, there is a residual volume. You cannot just exhale. I hope this diagram made some sense. Okay, vital capacity, sum total is giving you a little bit, these passages are not used for gas exchange, they are contained dead air. That's what he's talking about, residual volume, right? Okay, dead air and residual volume, the air remaining in the lungs after exhalation. Okay, control. Okay, your textbook did not, these PowerPoints did not give you the term medulla oblongata. Maybe it's in there and pons, but you know, there are chemicals, of course, they control your respirations. And he's talking about SIDS, sudden infant death syndromes that happens usually less than 1 year old. And we still do not know what cause of it is, but there are theories. So you're right here, if you look at your control center, this is the brain, and your control center is right here, that's in medulla oblongata. So a respiratory center regions, there are other places automatically regulates breathing. As I said, during inhalation, the atmospheric pressure rushes in, and then the expiration, the alveoli pressure is greater than atmospheric pressure, so the air goes up. And then, of course, he's talking about the intercostal nerves controlled by right here medulla oblongata, external intercostal muscles, and pharynx nerve, and then diaphragm. These are all of the components, the nerves that are stimulating these muscles to contract, and of course it happens automatically in medulla oblongata. The chemicals, of course, we could chemical breathing. The carbon dioxide, as I said, tissues produce that. And then chemoreceptors, sensory receptors that are sensitive to chemical composition of body fluid. Then your textbook talks about a little bit of circulatory system, carotid bodies and aortic bodies, which comes from the aorta. Make sure you study all of these, and you know I'm not going to go into details of them because I think this next picture should have a picture. Okay, right here, external expiration. So when hydrogens, ions are made up by your bodies, and then bicarbonate is a buffer which it will take the carbon dioxide, combination of these two, okay, it forms carbonic acid. That is an acid. Carbonic acid, bicarbonate is a buffer, as I said, and carbonic acid is an acid. So what happens, carbonic anhydrase, that enzyme, it breaks down this molecule, carbonic acid, into water and carbon dioxide. So carbon dioxide can be exhaled. Okay, so what he's saying, most of the carbon dioxide is carried plasma as bicarbonate ions. Okay, so, and then carbonic anhydrase is one of the enzymes on planet Earth, one of a few enzymes that it can drive a chemical reaction two ways. Okay, so if I may, I don't know if that's going to come up. Carbonic anhydrates can put together water and carbon dioxide and form carbonic acid. Okay, so that's an enzyme. I'm sure if you read it, it will come up. So hyperventilation, when you quick, fast, high rate, that's called hyperventilation. That increases, that's called, increases the pH of your body. It's called, it makes the blood alkalosis. Alkalosis, you remember in the past, I said the pH of your blood is 7.4 to 7.6. So if the pH goes higher than this, 7.6 become, for example, from 7.8, 7.9, becomes 8, God forbid, that is called alkalosis. Okay, and hyperventilating, and it's very dangerous, it can cause death. Acidosis, if a person is on a low rate breathing, I mean, they cannot breathe fast, it can cause acidosis. Okay, acidosis, if the pH goes below 7.4, it becomes 7.2, 7. Okay, that is all acidosis. Okay, as I said before, this is a physiological pH, 7.4 to 7.6. That's the range. Okay, so hemoglobin, of course, is a protein molecule in red blood cells that carry oxygen and carry carbon dioxide. Okay, so when it carries oxygen, they call it oxyhemoglobin. Okay, this is deoxy, without the oxygen, hemoglobin. And then internal respiration, oxyhemoglobin can break down to hemoglobin and oxygen, which internal respiration, when you talk about carbon dioxide, it's produced by cellular respiration. We talked about this. The formula for cellular respiration is, remember that, C6H12O6 plus O2, it gives you CO2, which you exhale, plus water, and of course, plus energy. That energy you need, you ate a lot of mashed potato this morning, right here, okay? And that's what you got out of it is the energy. And of course, you created carbon dioxide, which your body is getting rid of it by your respiratory system. You cannot have too much carbon dioxide in your respiratory system, it causes death. Okay, here it talks about the in the lungs, what happens in the lungs, that the red blood cells are picking up the oxygen, okay? And then they bring that oxygen into the heart pumps it to the rest of the body, that goes in, then these tissues could be your brain, it could be your liver, muscle, anything, your kidney, anywhere in the body. And what happens in the tissues, they give off O2, and the tissues, as I said in the last slide, right here, they do this. They have mitochondria with the help of oxygen and mitochondria, they give off carbon dioxide. So when they give off carbon dioxide, red blood cell again is ready for service. It picks up the carbon dioxide at capillary level and take them to the venules, and venules to the vein, and vein to the inferior vena cava. Inferior vena cava pumps the right side of the heart, pumps the blood into the lungs. And when the blood goes into the lungs, they dump the carbon dioxide. We exhale carbon dioxide. And then from atmosphere, we inhale oxygen. Okay? When we inhale oxygen, the cycle repeats again. I hope I made some sense. If you have any question during the review sessions, make sure you can ask these questions. Upper respiratory tract infections, of course, the strep throat that we get is by Streptococcus pyogenesis. You know, when you go to a doctor, they say you have strep throat right here. That's your strep throat. Then sinusitis is the inflammation of your sinuses right here. Otitis media, that is the ear, infection of the ear. As I said, you go to ear, nose, throat doctor. They should be able to identify otitis media. Tonsillitis, they removed my tonsils when I was a kid because I used to get tonsillitis so much. They were always infected during winter time. I was sick a lot, fever, you know, they said, and that's what they did to me, tonsillectomy right here. They removed my tonsils. Laryngitis, inflammation of your larynx, your voice box, so you cannot talk for a long time. Lower respiratory tract infections, restrictive pulmonary disorder, obstructive pulmonary disorder, lung cancer. Those are all acute bronchitis. Acute, as you know, it means quick, fast infections of the primary and secondary bronchi. Pneumonia, when your lungs become full of bacteria and pus and infection, then the alveoli cannot exchange oxygen and carbon dioxide, and that's used to be a problem. You can look up the stats. A few people die each year because of pneumonia. Tuberculosis is a bacteria which used to go away by antibiotics, still be treated by antibiotic, but it can cause, eventually it can cause pneumonia, cause death in a person. Restrictive pulmonary disorders, so fibrosis, you know, it's just, you know, when your lungs becomes full of asbestos, coal dust, people who are working coal mines, and then fiberglass material goes inside of the lungs and then cause restrictive pulmonary disorder. Obstructive pulmonary disorder, air does not flow freely in the air passageway. They call it COPD, COPD, chronic obstructive pulmonary disorders, emphysema, asthma. I didn't talk about asthma earlier, but let's talk about it here. Chronic bronchitis, it means the kind of bronchitis, inflammation of bronchus that chronic over a period of long time. Smoking can cause that, pollutants can cause that. Smoking tobacco and other issues can cause a lot of problems in here. Emphysema is a chronic and incurable. What happens, the alveoli, when you have 2-3 balls, you have 3 balls, I hope you guys can see this, you cannot see it. Right here, you have, okay, right here, you can see it. When these 3 alveoli become one, that's called emphysema. Okay, so why there is more exchange of gases here than here? Okay, there is less exchange of gases here than here, and that's why it's dangerous. The person can die eventually, for oxygen reduced, less oxygen reaches the body, most often caused by smoking. Elastic recording, I think I'll talk about it. Emphysema continued. So asthma. So what happens in asthma, your trachea is surrounded by smooth muscle. Of course, you have the C-shaped cartilage. Remember that? We talked about it. And then, of course, there is a smooth muscle around the trachea, bronchioles, bronchus, all of that. When that smooth muscle is contracting, it closes the air passageways for whatever reason. Pollution, I don't know, pollens, whatever is the reason. Some people have it, some don't, okay? So that's the asthma. When those smooth muscles contract, the air cannot go through. And that's what's called asthma attack, and they gave them inhalers and so on and so forth. Lung cancer, it can be caused by a variety of things, and then smoking is the most common factor of the lung cancer. Pneumonectomy, as you know, P is silent. Pneumonectomy is when they remove the lungs, remove all of lobes. The lungs, I forgot to mention this, very important. The lungs on the left side, they have 2 lobes. The lung on the right side, they have 3 lobes. Okay, on the left side, they usually do not remove it. If they have to, they will. I'm not sure, and don't quote me on that one. It has 2 lobes because of the heart. Heart is on left side of your body, so your left lung has 2 lobes, and then on the right side, you do not have heart, so it has 3 lobes. Okay, so anyhow, and then removal of a lobe or the whole lung is called pneumonectomy. Here is a cancerous lung and not cancerous, and that's the end of the material for this chapter.